Hello and welcome. Welcome to the exciting journey of DevOps. We have a journey ahead and we better pack up good. In this session, we are going to understand what is DevOps. Yes, you see that's the first step. First step is the most difficult one. But if you have taken the first step, then automatically your footsteps will follow. So journey is long, but you have to take that first single step. So come out of your comfort zone, buckle up, be ready. You're going to enter into the exciting world of DevOps. My name is Imran and I will be your trainer, coach and guide for this journey. I am a DevOps architect and consultant, and I also wear different hats. As right now I'm giving training, so I'm also a DevOps trainer. My core skills are DevOps and cloud computing, and I'm a professional certified into various areas of DevOps and cloud. Like I'm Red Hat certified architect. I have done certification in Ansible, Puppet, OpenShift, GlusterFS, OpenStack, and not to mention I'm also RHCE because that is the eligibility for this. I'm also certified in AWS, and also in my distance past I have done RHCE, VCP and Python certification. So that's about me. I just want to assure you that you are in safe hands. So now let's begin and start understanding what exactly is a DevOps. And we're going to start from the very beginning, from the development area, and then we will understand operations, and then we will see the problems and how they solve these problems. So we are going to go with some background before we understand DevOps. We are going to talk about software life cycles, how softwares are made, created, like apps on your phones, and then how are they delivered to you. So primarily you need an idea. So let's say this is you. Yeah, I know you look better than this, but just to understand the concept, imagine this is you. And you have a great idea, an idea of an app, a mobile app or software. And you know you can make millions if this idea really goes live and people start using it. So you decide to develop this product, but you don't have the skill sets. So you may approach a software consulting firm, or you develop your own IT organization. In whichever case, you need a team who can understand your idea, create the software from it, and then deliver it to the users. So the first step is requirement gathering. So there will be some specialized skilled people who understands the requirement, and they will come to you or you go to them, and they will take requirements from you and they will jot down the requirements. When you have an idea, you must be thinking from a user point of view, what the user needs in your app or what you are going to provide to the user. So there will be analysis of the user needs. They will jot down all the user requirement. They'll create a detailed functional requirement document, or documents, I should say. Once all the requirement analysis is done from the business analysts, they will go back to their team. And then comes the second step. In second step, now there will be some other set of people, skilled people who have the knowledge of designing, and we call them as architect. These architects will understand the requirement, all the detailed requirement, and they will design the system. And in this process, so many things will be decided. What programming language, what kind of database, what kind of storage, the software layers, different layers, how the development will be happening, all of that. And they will have a lot of system design documents or other documents and design documents. This detailed information will be passed to the development. In the third steps, the developer will get all this information on a regular basis, and they will start first coding. Before coding, they need some systems. So first there will be some systems set up. Developer will start coding. Once they're done with the coding, they will compile their code and create softwares. They'll write test files to test their software. There'll be setup and testing of databases also if it's required. And there's many more things that happens in the development. This will be the longest phase. And this is the place where actually the software gets created, which users are going to use. Next step is to test if that whatever was developed by the developer is going to perform in real time. So there will be testing, software testing, functional testing, load testing, performance testing, data testing, all the different kinds of testing. And if there are any problems with the product or with the code or with any tool, it will be reported back to the developers. It's fixed, and then it again comes back to the testing. Once testing certifies everything good, then it's time to implement the product, to pass on the product, you can say, to the user. So you'll be setting up production servers, storage, databases at a production level. And once all those servers, storage, database is set up, the developed and tested product will be deployed to these servers. And from here, the users will be given access. And then on, when the users start really using it, then it's about maintenance, the sixth step. In the maintenance, operations team has to make sure that everything performs good. There has to be good balance between stability and user demands, changes. As per the user demand or as per the product feature changes, there are changes that we deploy or implement into the servers, systems and databases. But at the same time, we have to make sure that the systems and softwares are stable. System health, performance, and the most important thing is uptime of your product. So let's see it in a more cyclic view now. So the first step is requirement gathering, then comes planning where the designing everything will be done. Then comes development. Once the product is developed, it goes to the testing. Once testing certifies it, it goes to the deployment phase, and then it is maintained. So this is the software development life cycle, develop and delivery. And here there will be different teams working on this. There will be architects, for starting from business analysts or even sales, then architects, developers, testers, system admins, the entire operations team, system admin, storage guys, cloud engineers, and support team and all. Now this is brief view. Now let's get into more detail. So in the development phase, when the developers are writing the code, they will build the code from the software, from the code, they create the software through the build phase. And out of many of the builds, some will pass, some will fail. Based on that, one build will be selected. One build means you can understand one software like that. That as of now. Then out of that, one build will be selected. Developer will say, okay, this is the right code and this is the right build. You can take this one and send it to the next phase. So this build or this artifact or this software will be deployed to staging environment or testing environments where it will be tested, evaluated. Once everything is certified by different testers and different teams in different users also, staging environment, there is UAT also, user acceptance test, set of user who will test the product humanly. Once they certifies everything, then only that particular build is moved to a production level. That means that product or that software is deployed to the production server. Right? Sounds really good. But when it is deployed to the production system, even after all those tests and everything, sometimes things don't work. Or many times, in some cases, things don't work. Right? Which are called as production deployment issues. So if we rewind back a little bit, the development work was done, testing was done, and then it was deployed to production system by operations team, system administrators, cloud engineers, storage guys, right? All these people, operations team. So if it fails in the production deployment, then the fingers will be pointed to the operations team. And developers will be like this. It's not our problem. We did our job. It's the operations problem because it's failing in production. Why? Why this finger pointing? Or the better question should be, why such kind of issues come? And we have to understand the operations team will deploy the product with the maximum possibility that it will work. The probability is it will work because it worked in the development environment, and that's what is the assumption. If it's working in the development environment, it will work the same in the production environment. But in reality, development environment testing environment and production environments are very different. First of all, they have different data. They're operating on different set of datas. Their network design is separate. Their security is separate. Production environment will be more secure, more highly available, more robust, and will have the latest real-time data. But when it comes to testing and dev environment, they'll be working on some old data. There won't be any security, any firewalls that is blocking the connection, so everything will work good. But in production, it will not. So that's one of the reasons. There are other reasons also. Really, the development has become very fast nowadays. New tools in the development and new process are making coding very fast. But the operation team is really not able to cope up with all this fast change and fast releases. So you can say there is more of a hurry today to deploy, to make new changes, because there's huge user demand also in the market that they need latest and greatest tools and softwares and features. So there is always this rush. Operations team responsibility is to keep the systems stable. If we rush, things will go wrong. And always production server, not always, but most of the time, the production servers will need some tweaking, some firewall changes, some database changes, which are not done, or which is mostly forgotten or missed in the transition. When it's getting transition from development to operations level, the development will assume it's already there in the production, whereas operations will assume that if it's working in dev, it will work in production. So these changes, OS level changes or security level changes, these are not done in the production system. That's why things go wrong. There are no clear instructions. The transition is very bad. So transition as in the information passing, the information the developer passes to the operations team for the deployment will be mostly a piece of document, series of steps that they have to follow to do the implementation or to do the deployment. Basically poor transition, which creates all this chaos and failures and confusions. The biggest problem is the manual build and deployment of the code. You have the code which we build manually. The test and all are also conducted by executing some series of steps, again manually. Once the software is ready, then it is deployed by the operations team, again that is also manually. This takes longer time. It's slow, it's error prone, because there are so many people working, so many commands getting executed. If any of the command by any of the user is entered wrong, or sorry, not user really, but the people who are responsible in build and deployment process, if any of them makes even a single mistake, the entire deployment process fails. It's error prone. Different environments, dev, test, staging, UAT, QA environment, production environment, different environments have different kinds of data. They are not consistent in nature. And we need a lot of documentation to do all this deployment. Now all this leads to long delivery times. We really struggle in chasing the deadline. And the biggest problem is the production deployment failures. So now let's understand how really the developers used to work and how they really work now. So initially they used to follow this traditional model, as we said, waterfall model. It's a software development life cycle, some set of rules or standard practices that they follow to develop the software. And it's a traditional model. It's still used in so many projects. It's not like it's not used now. But first we'll understand this, and then we are going to go and understand Agile. So waterfall model says everything has to be in phases. Once a phase is completed, then only you move to the next phase. Like a water fills at this level. The water is filled in the first level. Then it falls to the second level. So the first step or the first phase is requirement analysis. First, all the requirements are taken. All the user requirements, system requirements, all of that is jotted down. Like everything, all of that. Then once the complete requirement analysis is done, then it comes to design phase, where the complete product is designed. Assuming even its future, as in like what will be required in the future based on all that probability and everything. Actually, I'm saying that sarcastically, because later I'm going to come to a very important point at this phase. But let's understand this for now. The product is designed. And then once everything is completed, the design documents, everything are ready, then it comes to the development phase, where the product is developed, or should I say the complete product is developed, everything. Once the complete development is done, then everything comes to the tester where they have to test everything. You must focus on my words. I'm saying all, everything, all at once. These kind of words. Right, that's how it's done. Now, even the product are divided into different modules and separate. Now the work happens on different modules also, but this is in very brief I'm explaining you. So tester tests everything completely, whatever they have given, the complete product, and then once everything is tested, then it moves to the maintenance phase where we maintain the product. Now you'll say it sounds similar what you explained previously, and yeah, that's because this is based on this one only. But there are a lot of problems with the waterfall model. The first problem, I was stressing on the word everything. Once it comes to the testing phase and everything is getting tested, then there will be a lot of issues and a lot of errors, a lot of bugs that has to be resolved by the developers. And that many bugs, that many issues means they need a lot of time to fix all of that, and that will be so much of chaos and really panicky situation. So that's one big problem. Other problems that we have is when you're jotting down the requirements, when the client or the customer is giving the requirement, or in this case you are the client or the customer, you have the idea, you are giving the requirement, then you have to think about the future also, what the user may need in the future, and that's kind of difficult. In the designing, the architects have to think about how the technology is going to change in the future. Based on that also they have to design things, right? Again, difficult things, or should I say sometimes impossible, because all this process of deployment, of development and delivery is going to take time. Let's say it took 6 months or 8 months of time, then you have to wait that many months or that much time for the product to go live. You had an idea like 8 months ago, but now after the development and all, that idea may not be that much new, because it's like 8 months now and things are changing so fast nowadays. Even though if you have a new idea somewhere in the middle of the development, then here there is no place to inject new ideas. Overall, there are so many disadvantages. I'm sure there are advantages also, but we're looking at it from a very different angle. This model doesn't scale well in current time and situation. So the world has moved to Agile. So this, like in 2009 and 10, this Agile movement got kicked in very much, and people started adopting this model because this gives results quickly, fast development, fast delivery, and even the product is tested. How? Well, we're talking about the requirements and talking about jotting down all the requirements. Yes, it's the same thing, but those requirements are then broke down into small list of requirements. Like let's say you have 50 features to develop, a hypothetical number, 50 features to develop. So you don't need to work on 50 features at once from the beginning. You can divide them. Like let's say you work on 10 features first. So take those 10 features first, prioritized 10 features, plan on it, develop it, test it, evaluate it, understand where you're failing, learn from the feedbacks, and then deploy it. And then you can move to the next iteration, next 10 features, then next 10. Like that, you need 5 iteration in this case. If you have 50 features to develop and you're breaking down it into 10 features at a time, then there'll be total 5 iterations. And in every iteration, things can change. So Agile focuses more on iteration, break down the problem, solve it one by one, piece by piece. So take 10 feature, develop it, test it, and deploy it to the environment. Different environments like dev, test, QA, staging. Get the result, feedback. It's also showcased to you, as in to the customer, which we call it as a demo. So we'll show it to you that this is how your 10 feature looks like. And then the developer will the customer or the client may like it, may not like it. Based on that, you get more feedback, and those can be more improvised in next iteration. And you don't need to complete all the features. If you feel 3 iterations are good to go live, you can deliver the product before the complete product completes and learn more from the market, learn more from the user feedback. Now you see here there are so many deployments, and this deployment we're talking about staging or even production deployments. But before that also there are other deployments, deploying your product or your artifact or your code to test environment, QA environment, staging environment, UAT environment. So there are really too many deployments, that is a deployment request that is sent by the developers to the operations team, and that really is nightmare. Operations team is not able to cope up with all these changes. So yes, Agile is good. It has made development faster and better, but operation was still slow, not able to cope up with the Agile model. And because of this, then came the problem of development versus operations. So developer wants quick change, quick deployments, but operations team are not able to cope up, or they need more stability. Well, stability demands, you don't make frequent changes. Developers are demanding changes, operations is resisting it because operations needs stability. So now this continuous fight between development and operation. If things are not working, the blame game starts. Developer will blame that it works on my machine, it's not working on your machine. Operations will say that we followed the right step, it's the problem with the code. And because of this, really the business is suffering. See, we have come to a world now where the product is as important as its delivery. If you have a new idea that you want to inject in your product, a new feature, like I was recently discussing about the food delivery apps. Nowadays we get new food delivery apps, and they have now this amazing feature where you can see where your food parcel is currently. You can see the delivery boy moving in the map. This feature was not there previously, and user really, or the consumer or the customer really used to think about where is my food, or when it's going to come. They used to make multiple calls, but now they can really track. This is like a new feature, amazing feature, which is added in the app. So let's say someone would have this great idea to put this feature, but because of this DevOps problem, let's say the feature is created, but it is not delivered in the app. It's not deployed to the production server. So the idea is important, yes. Development is important, yes, but also the delivery is important. If the delivery is slow, sluggish, or not stable, users are not going to like it, and there will be business loss. So you must have so far understood that there is a huge gap between development and operations. And the solution? Bridge this gap. But really, is that so easy? Well, the first step starts from the communication. As I have told you initially, the dev doesn't understand operations work or overhead. The operation doesn't understand the development part. So there is this blame game that happens. The most important thing is better transition. For the better transition, you should have better communication. If both parties understands each other work, how it's happening, then they can give right solution and right suggestion. The second step will be working collaboratively, together working for the development and the delivery. And as in not just working together, but really collaborating the tools, the technologies together. These tools and technology will start understanding from later sessions. We integrate different tools and technologies together. So as the development happens, there are some tools that get kicked in, which will do the delivery also automatically, which is designed by us, DevOps. So as you have life cycle for the development, you should also have life cycle for the delivery. DevOps Workflow. I'm going to talk about workflow now. Now the code is created through the Agile model, you plan and the code. So we have seen in the Agile movement, plan, code, and then build. As soon as the build happens, every time there should be this test, which is generally called as unit test, integration test. This part you'll understand more in continuous integration, but every time the product is built, it should be tested. And this is not the software testing. This is the code testing. If that is being done, then that is called as continuous integration. Plan, code, build, test. So the tested code or tested software or product is ready now. Now it can be released or deployed to different environments. Like first you'll deploy it to development environment, testing environment, then QA environment, staging environment, delivered automatically with your automation tool to different environments, not manually, automatically. That is called as continuous delivery. Now, continuous delivery means deploy till the staging environment, not production. Production is not included here, because for production deployment you need approvals and so much of paperwork really. And I'm saying paperwork again sarcastically, you mean approvals, so many sign off and stuff like that. Then it can be deployed to production. But continuous delivery will focus on delivering the product till the staging environment, pre-prod, before the production environment. Once that is done, you're very confident about the delivery, you can do automatic deployment to production environment also, which is called as complete DevOps, right from the plan on code. From there, once the coding is done, you click a button and everything gets integrated and deployed to different environments. At the end, and also tested, and after the testing signs off automatically, then it is deployed automatically to production system. That's complete DevOps workflow. All of these steps automated. This can be more better understood through this image, DevOps lifecycle. So here are examples also of the tools that will be used in DevOps lifecycle. So whenever the developer writes the code, they will push the code to a centralized version control system, centralized repository of storing the code. One example is GitHub or Bitbucket, like that. So once code is published over there, then the code will be fetched and there will be some tests that will get executed. It will build the artifact or the software. Now, artifact is very initial word for you as of now. Little advanced word for you now, but you can understand as of now artifact as a piece of software. Okay, so from the code, they'll fetch the code, run some unit test, build the artifact and store the artifact. So there are tools like Jenkins which can do all of this operation. Jenkins can get integrated with different tools like Maven, which is a build tool for Java, and also tools like Nexus, which is a place where you can store your artifacts or your softwares. And this part is continuous integration. Fetch the code, run some test, build the artifact and store the artifact. This is continuous integration. And this is again in brief. Okay, there's much more steps over here. Once that is done, when the software is ready, now it can be deployed to servers. So you should have the environment already ready, servers, storage, database, everything ready. Or even if it's on cloud or virtual environment, that process can also be automated. So provisioning of environment or changes of the environment, this part can be also automated if it's on cloud computing, let's say like AWS cloud. If your servers, everything is hosted on AWS cloud and you need to make any change before the deployment to your infrastructure, that also can be automated. Once that is done, next comes the phase where you are going to use automation tools, or should I say configuration management tools like Ansible, Chef or Puppet, and which will take your software and deploy to right servers, make changes in the servers and the operating system. All of that can be automated through these scripts. Now I'm talking about configuration management tool today. Ansible, which is the latest one, then we had Chef previously, then we have Puppet also. And before that, we didn't have this tool. There was the era of scripting. But from the time the DevOps movement started, we had configuration management tool, which was Puppet and SaltStack initially. Now we have much more better, easier and advanced tools. So once the deployment is done, there will be functional and load test also will get executed. There will be software test cases written by software testers, which DevOps will execute from their code. So DevOps will write some automation code which will execute software testers test scripts, which will test the product in different environment, mostly in QA, but there will be tests. They can be tested in dev and staging environment also, and also in production environment. So all this test and all the deployment will be happening in dev, QA, staging and production environment. All this process all automated by using different tools, starting from a version control tool, Git, Jenkins, Maven, Docker, Nexus, Ansible, and different tools will do their work and you have to write all the scripts and all, set up all the right tools, integrate all of this together. And once that is done, you can set up a one-click deployment process where someone clicks a button and all this process happens automatically till it goes to the production environment. This is the complete DevOps lifecycle. Now, before this DevOps lifecycle, we had the word one-click deployments. The developer done with their coding and they just click a button which will trigger your automation scripts and stuff like that, right? All the different tools start working together. You see, like, in a big industries, core industries, there'll be big button. When someone press it, then all the machines start, the gears, everything will be started moving together and the product comes out, right? So it will be similar to that. Imagine that's a kind of machinery. So your machineries will be all your scripts. They have to be integrated and working together. So DevOps definition, final stage, really there is no definition of DevOps that I feel, because DevOps is understood from a different perspective. Some feel DevOps is all about automation. Some say DevOps is all about culture, but it's really mix of culture. It starts from the culture actually, communication and collaboration. That's the place where it starts. Then we start integrating all our different automation tools together to achieve the complete DevOps lifecycle. We should understand one thing very importantly. It's about delivery. We or DevOps are not developers and we are not system administrators. Our job is more logistics. Deliver the product safe, sound and quick. For that we use all the means necessary. Cloud computing, yes. Containerization, yes. Scripting, yes. Automation, yes. Jenkins, yes. Maven, yes. Whatever tools and technology we need, we will use to make sure that our product code features gets delivered quickly and efficiently. So that's the objective. Understanding that is the most important part. Then if you want definition, this is one of the definition that I found which I like personally, that DevOps is the philosophy of unifying development and operations team or operations roles at culture, practice and tools level. So it's not just about the automation tool. It's not just about the scripting. It's not just about the culture. It's about all of it. Agile is the culture of developers, but we have to adopt that culture. It starts from there. So you can't go okay, delivery has to be done, deployment, I'm going to wait for approval, these, that and all of that. You need to have a right process. First of all, right practices should be adopted to make sure that the product is delivered properly, and right tools should be chosen. So let's wrap up this by one final slide which talks about DevOps skill sets. See, when you understood the gravity of the situation, what all we need. Now what all we should have in us to become a DevOps or to perform in a DevOps project is, first you should have the systems knowledge. If you are going to automate some process, and you should know how to do it manually. First of all, you should know the operating systems. You should have the infrastructure knowledge, how network together works, storage together works, operating system, all this broad infrastructure knowledge should be there. Now it's cloud computing era. Everything is moving toward the cloud, and it's very good for us because if it's on the cloud, we can automate infrastructure part also. So you should have great cloud computing skills. Great. Okay. Very good cloud computing skills. And you should be understanding how the developer works. And I'm saying understanding, not really doing it. You are not developers. Okay. DevOps are not developers. So we don't develop the code and create the software. Okay. We don't do it. Our job is delivery, automating the process of delivery. But it starts from the product. So you should understand how the product is developing, SDLC, all that knowledge you should have. You should be understanding the build and release process, the automation of it, continuous integration, and also very important, automation of OS tasks, executing commands on the operating system, Linux commands, Windows command. You should know how to automate those processes. And then you should be able to combine all these automation tools and technologies together, which is called as orchestration. See, it's not about you who is writing all the automation code and everything. It's about everybody in the team performing and giving you automation code. Like for example, software tester. You can't have a manual tester in DevOps. You need an automation tester who gives you automation test scripts which you will execute. Being DevOps, we don't write software test cases or scripts. What we do is we take their script and we execute it in our life cycle. Same for SQL deployment, database deployments, security testing. All this we need different scripts. No manual step. Everyone should automate their steps and it should be given to the DevOps. DevOps will integrate everything. So you should have the complete orchestration knowledge. Network and security knowledge is also important because we'll have different servers, different IPs and ports which are connecting and working together. Security in between them, their firewalls. These things is very important in cloud computing. And also finally containerization. Now is the world which we are switching to containers world. So you should really have a good knowledge on Dockers and containers. And this course is going to be based on all this skill set. We're going to work on developing and enhancing the skill sets. We are going to start from the very basics and then slowly we're going to move to automation. So really the foundations are important. So I recommend you go slow, do not rush in this course. Practice each and everything. Understanding a concept is more important than by hearting a command or by hearting set of commands. Don't go for by hearting. There's so much of information flowing here. If you start by hearting, then you'll be too much overloaded. You need to understand more the concept. Concept building can be done only through practice. So practice, do not rush. The course is designed like that. It's building block. Once you learn a technology or a tool or scripting, the next session will be based on what you have learned previously. So you don't jump only if you are good in that particular technology. Like if you already know how to do bash scripting, then you can directly move to the Python scripting session. Or if you already know Python scripting and all, then you can move to the next sessions like that. If you already know Vagrant and VirtualBox, you can move directly to scripting. You don't need to do Vagrant. Okay, but if you don't know, do not jump. Or even if you know the basics of it, still go through it. Do not just watch, practice. I wish you all the best in developing all these skills. Thank you very much for choosing this course, and I hope you follow the journey till the end. Thank you very much for watching. I will see you in the next session.